Thanks for stopping by. Innovative Cymatics. Brand new page. This is actually my first narrated video, so you're going to have to bear with me. I'll get better as it goes. So this is the first video I posted a couple nights ago, and I just wanted to give some explanation on it. Basically what's going on here is this is the first capture software that I wrote. It's a Python script. And what's going on here is I set up a given frequency range. I think this one was from 20 to 30 hertz, and then I changed the amplitude, and then I used an edge detection algorithm to kind of detect certain edges, and that's where this AI score is coming from. And so when it feels that it's looking at a cymatic, it's just going to automatically capture a picture. And what I found that this really didn't work out all that well, because there's this moving water. There's a lot of, it captures noise. It's kind of indiscriminate, and it wasn't intelligently looking for cymatics. It was just looking for the edge. A little bit more of what's going on here. You'll see this decay here. That's more of like an averaging. So as the cymatic is moving around quickly, I think I have a spot here where I can show what the live image looks like. Yeah, this is the live, basically straight from the camera. And this is at 30 frames. I actually see it a lot faster, 60 frames and up to 120 on my actual capture device. But the averaging through the decay is quite important. Otherwise, AI kind of has a hard time catching up with it. So what I'm working on now is more of a intelligent approach to capturing these cymatics. So the next script that I wrote just captures the images, and they're indiscriminate. It doesn't try to analyze it whatsoever. I tell it where to go, and I tell it when to take a picture. Given frequency, given amplitude, take a picture. Move to the next step, take a picture. And this particular run with 946 photos was took about 2 hours to run. And what I'm doing now is I actually, this is pre-recorded, but I have hotkeys, A and D, and as a cymatic comes up, I click either A or D. So it captured all of these 946 images. I then go into that folder and I run a secondary script to basically separate patterns from noise. And what I'm doing here is this is the transfer learning method that I'd mentioned, that will take these two positive and negative buckets, and then I will use the ResNet learning to determine what's good and what's bad. And when I have enough of this data, when I start running these scripts and I run my newer, more enhanced or intelligent AI algorithm, it will automatically start looking for some of the examples that I asked it to, or things that are similar. So, for example, this would be something I would absolutely call a pattern. All of these ring ones, these are all noise. What's going on here is the amplitude's just not high enough yet, and it hasn't broke. So you'll get these rings and they'll just kind of sit there. Sometimes when we get too high in amplitude, we'll get this type of noise. So basically, each given frequency has its own kind of sweet spot. So again, the process that's going on right now is just teaching my AI what's good and what's bad. And this is going to be a long process. I'm going to have to get several thousand pictures in each one of these and run my learning script over and over again. And eventually we'll get to a point where no matter what frequency I'm at, no matter what the situation is, no matter what the amplitude is, it's going to say this is a cymatic or this is noise. And we'll see where we go from there. But that's kind of the baby steps to my my thought process on how to capture these in kind of a systematic way, and starting the catalog process for later analysis. So hope you enjoyed. Thank you.